Hello everyone, welcome to a new episode of CPP tutorial video. Today we will study about a very useful C++ idiom called Cheshire Cat idiom. This C++ idiom is about the guidelines that every C++ interface must follow. Such an interface has got lot of advantages, saving a lot of time and cost in terms of maintenance and binary compatibilities throughout the full software development. I strongly recommend you to watch the complete video without skipping any bit of information. In this tutorial video, we will discuss about what is Cheshire Cat idiom, concept behind the idiom, merits and demerits of Cheshire Cat idiom, good practice to be followed, and finally an example with all good practice. Cheshire Cat is a fictional cat in movie Alice in Wonderland. It is a very famous movie where the Cheshire Cat movie character played some important roles. So, what is significance about Cheshire Cat in C++? We will come to know this point in a very short time. One of the distinguishing features of Cheshire Cat is that its body part gets disappeared time to time. The last thing visible is the cat's iconic grin. Grin means a broad smile. So now you would have got some hints. In computer programming language, the Cheshire Cat idiom is about hiding some part of a program. Hence the name Cheshire Cat. Cheshire Cat idiom is also known as compiler firewall idiom, deep pointer idiom, handle class, PIMPL idiom. PIMPL is the short form of the pointer to implementation. The idiom is most commonly known to the program world as PIMPL idiom. PIMPL idiom is based on the concept of opaque pointer. Opaque means something that cannot be seen through. Opaque pointer is a pointer in C++ that's point to a data structure. Since it is opaque, the content of data structure is not exposed at the time of definition. The most highlighted advantage is that opaque pointer helps to hide the implementation details from its client. This is why this idiom is also called as Cheshire Cat idiom. Let's consider an example. In this example, we will write a program to develop a car application. The requirement is to develop the different modules of a car as independent libraries, such as frame.dll for car frame, engine.dll for engine, gearbox.dll for gearbox, etc. The car application shall use these independent modules for completing the car application. Let's start with the example. Let's assume that the integration of engine, frame, and battery parts are all completed. Now we want to integrate the gearbox functionalities in car. For that, we need to first import the library gearbox to the car project. Once this is done, we can start using the gearbox library in our car application. As shown here, the gearbox library provides features like change gear, neutral, reverse, etc. Let's try using the feature change gear. For using the change gear method, it is required to include the header file gearbox.h. This header file contains the interface of gearbox in which the change gear method is implemented. Now, as you can see in the figure, the car application have compile time dependency with the gearbox.h header file. If you closely check the gearbox class, you can see that the class have a private member variable of type gearAssembly as a stack object. Using this variable, the gearbox class internally manages the various functionality it provides. Because the class gearbox has to use the private member variable of type gearAssembly, the header file gearAssembly.h is also needs to be included in the gearbox.h header file. This additional include just added a lot of maintainability overheads. When client modules include the interface gearbox.h, the gear assembly header file also gets included in the client modules unnecessarily. The client application is now unnecessarily coupled with the internal details of gearbox library via gearassembly.h. Because of such interface design, the car application is tightly coupled unnecessarily with the gear assembly class, which is induced through the exposed gearbox interface. Such an interface has got lot of disadvantages. It induces unnecessary dependency in client modules or applications. It is required to rebuild the client modules every time when the internal class is modified. The number of patch binaries is increased due to the unwanted coupling with the unnecessary interfaces. The build time increases as whenever the internal class is modified, it is required to build the client modules also. Every time a modification occurs, all the client applications are also has to be built and overwritten in products. This increases the chance for new issues. The binary code compatibilities issues also gets increased. That is, if any one dependent module is not properly built and used, the application may not work properly. Now let's redesign this gearbox interface using PIMPL IDA. First thing we need to do is remove the header file gearassembly.h from the header file gearbox.h. Once the header file gearassembly.h is removed, the gearbox library will not compile as we have a private member variable of type gearassembly. So we should somehow avoid this member variable. Here comes the importance of using opaque pointer. Instead of using the gear assembly variable as stack object, according to opaque pointer concept, change the member variable to a pointer type. Also, the class type is specified as private in gearbox interface by using forward declaration. Now, the gearbox.h does not include any internal header files. Hence, the client modules that using the exposed interface using this header file is not coupled with any unnecessary header files. So now onwards, none of the client applications that include the header file gearbox.h need to be rebuilt if any changes occurs in the header file gearassembly.h. The benefits of PIMPL or Cheshire Cat item are simpler interfaces. There is no unnecessary private members or functions available in the exposed interfaces, thus providing a very thin interface. Client cannot dereference the opaque pointers. Client application shall not get any clue on what is inside the opaque pointer. Client cannot dereference the pointer without knowing the class definition. Minimized coupling and breaks compile time dependencies. There is no unnecessary dependencies included, thus minimizing the coupling and avoids any unwanted time dependencies. That is, there is no compile time dependencies now. Allows binary code compatibility through different versions of a shared library. This is because now the patch file number is reduced. In our example, if a bug fix is done in gear assembly class, then the only patch file is gearbox.dll. No other modules are affected due to the modification. Reduce the build time as the client applications are not coupled with any of the internal details of gearbox library. There is no coupling. There is no tightly coupling between the client applications and the gearbox DLL. So this reduces the build time. The client applications are not required to build anymore. Localize the code modification impact to the module. It is not opaque. Only the modified library are impacted and need to be tested and ensured correctness. Even though there are a lot of merits, there exists some small demerits for PIMBL idiom. The first one is that size of interface is increased especially for interfaces with only member functions. Here the PIMBL idiom is followed to avoid exposing private functions to clients. The usage of opaque pointer causes the size of interface increased by the size of a pointer. That is 4 bytes or 8 bytes based on x86 or x64 architecture respectively. Performance penalty. Performance degradation can happen due to an additional memory allocation of pointer member variable or used for the forward declared implementation class. The amount of degradation depends on the allocated object's internals. In most of the scenarios, these demerits are very insignificant and might be ignored when the merits are considered. It's upon the developer and the space or time requirements one should use the PIML idiom in the program. Now let's discuss about some of the good practices that can be followed when using PIML idiom. First one is use smart pointer as the opaque pointer. The freeing of opaque pointer is automated when smart pointer is used. Use std unique ptr or std shared ptr instead of using raw pointer as PIML pointer. Always prefer using std unique ptr over std shared ptr whenever possible. Use an internal implementation class as opaque pointer. Forward declare the implementation class type as private. This prevents the object creation of implementation class from other classes. That is, only the interface class implementation can create the objects of its privately declared class. Mirror the exposed interface inside the implementation classes. Move all private member functions and private member variables from the exposed interface to the implementation class. Let's see some code snippet for explaining this. Here, the left side code snippet represents the client side code. In our example, the car application code, as shown in figure, includes the header file gearbox.h from gearbox head library. In the program, the car application is using various functionalities of gearbox library such as change gear, neutral, reverse, etc. Here, the right side code is the interface of gearbox. It does not have any unwanted internal include files. The right side code is the interface of gearbox implementation class. Now let's see how we can write PIML using implementation class. The left side is the gearbox exposed interface class gearbox. Right side is the gearbox IMBL class which contains all the implementation of interface functions exposed by the interface class gearbox. As shown here, the gearbox contains the forward declaration of class gearbox IMBL as private. Gearbox interface contains an opaque pointer to the forwarded declared gearbox IMBL class type. Here, std unique pointer is used for memory handling of opaque pointer. As you can see, the gear assembly header file is included inside the gearbox IMBL. Here, since the gearbox IMBL class is only an internal class of library gearbox dealer, no one can access this class outside. All the public interface functions in the interface gearbox are also defined in the gearbox IMBL classes. In addition to this, gearbox IMBL now contains all the private members and functions which are required for the working of gearbox exposed functionalities. The benefit is that these functions are now avoided from gearbox class and hence it is not available to other client modules directly. All the private functions and private variables are removed from the main exposed header file. Now let's see the implementation side of Gearbox and Gearbox IMBL classes. The gearbox.cpp includes the gearbox imbl.h before including the gearbox.h. Now, the compiler knows the definition for forward declared class pointer in its header file. Corresponding to each public interface in gearbox class, there exists same function in the implementation class. As it is shown here, the gearbox IMBL implementation class performs the actual work. Gearbox functions just delegates the call to corresponding implementation class functions inside the gearbox IMBL class. In this tutorial video, we have discussed about C++ PIMBL idiom, its merits and demerits, the good practices, and a small example. Please keep these points in mind whenever designing and expose interfaces. It helps to keep the interface cleaner and thinner. Please let us know your doubts, suggestions, and comments in the comment section below. If you have not yet subscribed to this channel, please do subscribe. Also, press the bell icon for getting notifications about future videos. Please do like and share with your colleagues. Thank you for watching the video. Have a good day.